refactor and built and had 158 errors just because I had to go back through and thread all that new functionality. Just ask what libraries we're using. So we are doing a series of kind of like code katas and instructional kind of stuff for C# and design patterns. And then I got this wild idea that it'd be fun to take what we've learned and apply it to a game. So we're building all this from scratch using only what we cover every week. So custom game engine, not going to be anything crazy. It's not going to set the world on fire, but it will serve as a pretty good exercise to, like we're in week 4 now, and so we've done the factory pattern, the strategy pattern, the bridge pattern, now we're doing the command pattern, and taking a real life example and seeing what problems they solve and what problems they don't solve. Okay, so our base game object as an abstract class immediately says you have to implement this, right? And I have the ability to implement it abstractly. So I'll do that. And so now I'm kind of passing the buck along. I'm kind of passing responsibility. I'm saying that, well, I don't want to implement this as the base game object, but whatever inherits from me will have to implement this. So by doing that, our errors increase, right? Because now everything that inherits from base game objects complaining, you gave me this new responsibility, and I can't do that. Why would you do this to me? All right. So let's go into base actor. And we already started to do this here. So thanks to the power of inheritance, and we can see this now, that I can say override. So the error that's giving me is that my implementation here is going to hide the contract I've made with the base actor. So what I want to do instead is override. And so this satisfies that contract, that abstract method that we said everything that implements our base game object should also implement this. We're just baking in functionality. We're saying, well, we don't want to have to implement this for everything that implements base actor. We can just have base actor handle this responsibility. So the buck's going to stop here. And so I'm free to do, we don't have a repair inside of the base actor. That could prove problematic. We have fight and heal. And our player has repair and negotiate. Interessante. So now's a good time to ask ourselves, now that we already have, we're saying that all game objects should be able to respond to actions, even if it's to say that we don't want to do that thing or we can't do that thing. So we should probably move these two especially back down into the I game object contract, so that not only are we requesting that everyone can respond to a command request, we're also saying that everyone must have the mechanism to do so. Hey Guffin, it's going to be Guffin asked if it's going to be a game with a GUI, and it's not. It's going to be an homage to the old multi-user dungeons. So a lot of the creativity is going to come from your classic D&D stuff, but it's going to be a zombie survival game, but it's going to be turn-based. So while later on we can decide to do whatever we want with the business logic, right now we're just going through and we're seeing what a game engine and what modeling players and inventory and algorithms for behaviors, what all that looks like. So as core business logic, the presentation tier or the GUI, it's agnostic to that right now. When it comes time to decide how we really want to implement that front layer, we're going to have a really good foundation to do whatever we want. All right, so let's take a step back to the base game object. Let's go to the iGame object. So we've got take damage and restore health as our two basic things. I'm going to click around real fast to refresh myself to this architecture. Actor has fight and heal. So we want to take this out. Instead of our iGame object, while everything has a take damage, we also want to have a fight and heal. iActor and the base actor, take out, leave those in. Take them out of iPlayer. I apologize for the jumping around. Just as we get more and more files, more complexity, it might be a little harder to follow, but okay. And a good point to make here is that at first we were able to get by just by having them return a double. Eventually we're going to want these things to return something a little richer than just the double value. But that is a bridge we don't have to cross quite yet. Okay, so we took the 4 basic actions in a game and we put them in the base game object. And we said, hey, you have to implement these no matter what you are. So hit build again. We're just going to use that. 22 errors now, and we're cooking. Okay. So let's go ahead and pick this a bit. So we go back to our base game object. And we can implement these as abstract. And ReSharper is going to be great about this and say, hey, do you want to implement all 4 of these? I'm going to say yes. So let's go through this list again. Base inventory item. Not a whole lot here. And let's go and implement members as abstract. And you can see for this one we're pulling in that execute game request as well. You see this list just keeps growing and growing and growing and growing. It's because we've got all this inheritance built in. So let's start with our base inventory item to show how we can clear some of that up. Instead of doing this abstractly, we're going to override it, meaning that we're going to provide some base functionality into our base inventory item. So they're items, right? So we're going to do something very, very similar to what we did before, which is var action type is equal to request dot action. We're going to pivot on that. Oops. And here we're going to say case. Okay, so you can't heal, right? Like we know that for all items. Yeah, Geffen. All we're really doing now is business logic, but we're also doing some scratch work over here to see how that business logic is actually playing out, mainly as a way to demonstrate the patterns that we're learning. But once we start working on our game engine, at the end of week 4, we should be at a place where we can actually start playing the game and doing this kind of end-to-end testing of or exploration and discovery of what we want to do next. All right, so you also can't negotiate with an item. Okay, hang on real quick. This all looks and feels good. Oh, whoops. Nope, that's good. We'll come back to that. Let's get rid of that guy. Alright, so I knocked out 4 errors, and you'll see that most of the errors are going to be in the implementations, those concrete implementations. So in a lot of the places we're going to be able to cut off those errors by adding some basic functionality. For example, is here in our player. This is probably our meatiest abstraction because we've done so much work here. So first of all, let's go ahead and just implement the missing members, fight and heal. And we already have those defined. Wait a minute. Repair. That's interesting. So let's make these, let's override these so we're not hiding the same way we didn't want to be before. So we can already see that we don't necessarily have to redo a logic. We're incorporating what we already have into this kind of evolving architecture. And it might seem like I had like a lot of foresight in doing this, and I really didn't. There's just this nice consistency that comes along with following design patterns, that you're always abstracting something, you're always using pretty strong inheritance throughout, you're trying to follow some pretty basic guidance. So when you have to go back and refactor, you have to tweak some things, they seem to naturally click together. And it saves you a lot of pain because everything is kind of threaded through these basic principles. We really haven't done much with this guy. We're going too soon, but let's go and return 0.